Welcome to a lesson with Dr. Powell. Let's find the length of a curve in polar coordinates. We're going to do the cardioid. R is equal to cosine of theta plus 1. This cardioid looks something like that. And you can see that from this graph with theta and R. We just shift cosine up 1. It's something like this and this. So if we go between negative pi and pi, notice that pi, the R value is 0, and it just builds up until you get to 0 right there. And similarly the other way. So we have this, and we want to find the length of the path around, or the perimeter of this cardioid. So to do that, we're going to use the format we have for finding arc length, which is r prime with respect to theta squared plus r squared. And that's what we're integrating with respect to theta here from 0 to 2 pi. So let's take the derivative of this with respect to theta, and we'll get negative sine, then we square it. So it's positive sine squared theta. Just take that and square it by foiling out, and we would end up getting cosine squared theta plus 2 cosine theta plus 1 square root. And we're integrating this from 0 to 2 pi. Notice this is an identity, that's equal to 1. So we end up getting 1 plus 1 plus 2 cosine theta. You can factor out, a 2. In fact, let's do that to begin with. Factor out a 2. We have a 1 plus cosine theta. Remember, this is 2 plus 2 cosine theta. So pull out the 2's and you're left with 1 plus cosine theta. Now we could even go further and factor out, or we could factor out a 4, or you could just think of, let's do it this way. Let's think of just putting a 2 divided by a 2 here. Just snag a 2 on the top and the bottom, so that's fine. And this enables us to be able to use an identity here. So we're going to be thinking of this right here as 4. And remember, this is still all underneath the square root, d theta, going from 0 to 2 pi. Take a square root of that. Okay, and we're going to think of an identity here. Now, this is equal to cosine squared of theta over 2. So we have an identity here. If we take this and double it and put it here, 1 plus cosine of 2, whatever this is, all over 2, this is an identity right here. So we can use that. So when we take a square root, we'll end up getting 2 times the cosine of theta over 2. But keep in mind, technically, this will actually be absolute value, since this will be absolute value. And the reason why this is absolute value right here is because we have a square root of a square. And there's no way to get negative out of that. So that'll always be positive. Now, remember, we're going from 0 to 2 pi. Okay. Now, on the pathway from 0 to 2 pi, the cosine graph actually, let's see, so 0 to 2 pi, but we have theta over 2, which will be going from 0 to pi. Okay, let's think about that for a minute. So we're going from 0 to pi, and the cosine curve right there will look something like this. Notice it'll cancel out and be 0. Oh, we don't really like that too much right there. That's not going to work for us. But notice that we didn't have to go from 0 to 2 pi all the way around. We could have, to get this perimeter, we could have changed our bounds a little bit from 0 to 2 pi, so we could at least get everything. Maybe we could have gone from negative pi halves to pi half, I mean negative pi to pi, starting from this point. So if we were to do that, we would still have the same integral, But the benefit is that we don't have to worry about absolute value anymore, because then that would be theta over 2 goes from negative pi halves up to pi halves, and notice cosine is positive there. So we could erase the absolute values now, and we're set to go. So now we can integrate this just fine without worrying about splitting it into parts. And okay, so we take an antiderivative of cosine, which is sine. We could use a u substitution here, which would be like dividing by, but in essence, what we're doing is we're dividing by half, which is like multiplying by 2 here. So we end up getting 4 sine of 4 sine of theta over 2, evaluated from negative pi up to pi. Okay. We plug in pi, we end up getting pi sine of pi halves, which is just 1, so we get 4. And then over here, if we plug in negative pi halves, we get negative 1, but we're subtracting it, so we get negative negative, so that's like plus 4, which should be 8. So the length of this, or the perimeter of this cardioid shape all the way around, is 8. Thanks for watching.